To go from polar equation to rectangular, you need to use the formula that x is equal to r cosine theta and y is equal to r sine theta. Now, when it comes to changing equations to polar, which seems to be doing the opposite direction, but when you're going from points, this is the formula you use for here, and also for equations, to convert this into polar, it's the same equation. Occasionally, you might need r squared equal to x squared plus y squared. So let's see how these three formulas are being used for these questions. This one's an easy one. You just have to do x equals to negative 5 times cosine 5 pi over 6. And the exact value for that is, let's see, it's over here. So negative, we're at 3 over 2. So it's 5 square root of 3 over 2. And then y is negative 5 sine 5 pi over 6, which is positive 1/2, so you get 5 over 2. So the answer for this is simply 5. Oh, sorry. Is this right? Just a minute. Oh, I forgot a minus here, sorry. Okay. So that's what you get if you convert. It's just simply applying the formula, that's it. Now, to convert equations into polar, you use the same thing. However, sometimes you notice that you have x squared plus y squared, so simply change that to r squared. And then y is replaced by r sine theta. Now, if you see that you can divide by r, you can do that. Well, there are some exceptions, but I don't want to go into that. You just do that, and then you get r plus 4 sine theta equal to 0. And what I didn't write on the board is that your polar equation should always be in the form of r equals to f of theta, or theta equal to constant, okay? So you have to solve this for r. And that's the equation for this one. By the way, this is a circle that's touching the origin with the center at negative 2. Negative 2 in the y-axis. Okay, so you can do complete the square to see that that's what you get. And if you convert to polar, this is the equation. Okay, y equals to 4. Again, same idea. You could say r sine theta is equal to 4. And because you have to solve for r, you get r equals to 4 over sine theta. Yeah, that's it. Now, this would be given full credit on an exam, but it's also good to know that 1 over sine theta is known as what? Cosecant. Cosecant. Therefore, you can rewrite this as r equals to 4 times cosecant of theta. I'll probably not put this on the exam, but occasionally you might see an equation that looks like this, and you would never know that this gives you a line unless you multiply sine both sides to cancel this one, and then rewrote r sine theta as y. And this one, what is this one? This one is a horizontal line, right? So, just having theta go from 0 to pi will give you this entire horizontal line. Okay, what about this one? This one is this is an exceptional case where when you draw the graph, it's easier to see what's going on. So for every point on this, if you view it in terms of the polar coordinate system, what commonality do those points have? What's common about all these points when you think about its polar coordinates?
Pi over 4.
45 degrees, right? Yeah, they're all 45 degrees in terms of this, okay? And if r is 0, 0 comma 45 degrees will give you this point. Say 1 comma 45 degrees is going to give you this point, and then 2, and then if you go negative 1, and you get this other point. So this one you can just use the graph and say, oh, this should convert to theta equals to pi over 4. Now you could try doing what we've been doing before, but that's going to be slightly harder. Well, it's not impossible. You just replace y and x by these two, and you get r sine theta equal to r cosine theta. And seeing that r is common, you divide both sides by r, and you get what? Sine theta equals to cosine theta. And then if you divide both sides by cosine theta, you get sine theta over cosine theta equal to 1, which means tangent of theta is 1. Yes?
Do you have to add pi k?
Okay, yeah. Actually, okay, so to be even better, you could add pi k, and you could also put plus or minus pi k, okay? That would be all possible solutions, but my goal is just to get one equation that works, okay? This is just one equation that works. If you do this, when is tangent theta equal to 1? It's true when theta is equal to pi over 4. Oh, no, negative doesn't work. Sorry, you're right. Just plus minus pi k is the answer. So this works, but tangent function has a period of pi. So if this works, plus pi is going to also work, plus 2 pi will also work, or minus pi is going to work. You can add or subtract by any multiples of pi, and those angles will still satisfy this equation. Okay? So by doing so, you can say this is one correct answer. You could also say theta equals to 5 pi over 4. That's another possible correct answer, and there are so many, infinitely many possibilities. Okay? Yeah. But my goal for this question was just find one equation that does the same thing. Yeah, I didn't expect that comment. That was brilliant, right? Okay, now what about this one? Last one, y equals to x squared. You just do r sine theta equals to r squared cosine squared theta. That's because x is r cosine theta, and you're squaring it, so both of these get squared. And then you can divide both sides by r, and you get sine theta equals to r times cosine squared theta. Okay, for this one, again, because the requirement is to write it as r equals a function of theta, if you can, we should divide by cosine squared, and you get r equals to sine theta over cosine squared theta. And again, this is going to be given full credit. However, if you wanted to rewrite this in using the reciprocal function sine, this can be written as sine over cosine times 1 over cosine. Sine over cosine is tangent. 1 over cosine is secant. So another better answer would be this one.